Hi, this is Buzz Wilson speaking to you from an internet poster presentation. Recently, I visited the Field Museum of Natural History in Chicago to look at a collection of isopods from wood accumulated by Janet Voigt. In looking at this collection, I discovered some interesting new species and realized that while we know a lot about isopods and isopod species richness in sedimentary samples, we know not a whole lot about hard substrates and animals that are found on wood, for example. So today I'd like to tell you a little bit about these isopods, but first I want to quickly go over food input into the deep sea, discuss the prevalence of wood habits from several different viewpoints, and look at the emplacements that Janet and colleagues made in the Northeast Pacific. That's a picture of Janet in the lower right. I'll show you the isopods on wood and discuss the interesting connection they have with faunas that live in the southern hemisphere and compare the overall species richness of these with other faunas in the Pacific Ocean. Now, food input into the deep sea is typically from surface production sinking to the sea floor. This might consist of algae or zooplankton particles, marine snow, such as the larvation housed to the side, or large carcasses such as whales or fish. In some localized areas, you can get bacterial-driven chemosynthesis in reducing environments where you see a lot of hydrogen sulfide, such as hydrothermal vents, cold seeps, and large carcasses such as whales. But of course, some material gets into the deep sea from external sources, land rivers, marine canyons, in particular marine algal masses, or wood, which is my subject today. So how common are wood habitats in the deep sea? Well, we know that wood enters the oceans constantly from rivers, and much of this will enter the deep sea as it becomes waterlogged and sinks. But one thing that we may not realize is storm events sometimes can produce huge amounts of wood that gets into the oceans and eventually into the deep sea. For example, a single event, a typhoon off Taiwan, produced an estimated 4 million tons of woody debris that is shown in this picture here that would have gotten into the oceans around Taiwan and eventually sunk into the deep sea to become things like the material shown. Now, how common are habitats in the deep sea can be also looked at from the point of view that, well, there's a fauna that's specially adapted for living on it. In particular, one thing we know a lot about thanks to Ruth Turner and Janet Voigt's studies, the boring bivalve Xylophaga, which burrows right into the wood. But also living on the wood are mussels that are found around hydrothermal vents, and so they're as well as on the wood. So there's some sort of connection there. But there's also peculiar things like Xyloplax, the sea daisy, which is originally thought to be a class of echinoderms on its own, but more recently is shown to be an asteroid with a juvenile form. But also you can have small macrofaunal-sized organisms such as the Taenid Proteinaeus, as studied recently by Kim Larson. Another way of thinking about the importance of wood environments in the deep sea is that it does appear in the fossil record. There's at least one report of a Cretaceous assemblage of deep water sediments that have woodfall organisms such as shipworms and snails. And these species are similar to those that are found on plesiosaur bones and hydrocarbon seeps in the same sediments. So how do we study wood in the deep sea? Well, typically and traditionally we've gotten wood by either trawl or dredge samples, and Janet has some samples like this in this collection, but these samples have no knowledge of how long they've been on the bottom or what kinds of specimens are really associated with it. And during recovery, some of these small organisms might be lost. Some of these issues can be addressed by using wood emplacements where you put down wood blocks and recover them at a known time later. And the nice thing about this is that you know the time of the bottom and you have the ability to collect all associated organisms. I should point out that this study was begun by Ruth Turner back in the late 60s, early 70s. Ruth was one of the early investigators on the Alvin and was the first woman to go down an Alvin. Janet and colleagues made a number of emplacements in the northeastern Pacific on the seamounts there. In particular, the Escabana Trough from the bottom to the top, the Gorda Ridge, the axial volcano of the Juan de Fuca Ridge, and the Endeavour Seamount of the Juan de Fuca Ridge. And she's also has materials from the Cascadia Basin, a number of localities there. The deployments were made in 2002 using the Mbari Rove Tiburon and the Hui Rove Jason 2, and the recovery was done in 2003 with Jason and 2004 using the Alvin. Another site that she has shown in the blue oval is a Johnson Sea Link dive from 614 meters. This is a wildwood fall, and I place it on a map with another study, the Deep Gulf of Mexico benthos study conducted by Gilbert Rowe and colleagues, just to indicate that there's a large body of information about the fauna from the background sediment community. The wood emplacements, as I said, were put out in 2002. These consisted of fir and oak blocks, both that were placed in dive bags. And then during 2003 and 2004, they recovered the bags and discovered that, in fact, a lot of these wood blocks did have a lot of biological activity, as shown by the xylophaga borings in the lower right. The emplacements were made on soft sediments in some cases, and I'd like to get you to notice that after the blocks were picked up in at least a few indications of hydrogen sulfide through the dark reducing sediments. And the emplacements were also made on rocks or near rocks, and you can see a lot of megafaunal activity around those blocks. The isopods associated with the wood at all localities, I looked at 29 total samples, of which 14 came from wood or sediment under the wood. We had quite a few species. Most of these are ones that you would expect to see in the background sedimentary community, but I've marked a few of them. In particular, Limnoria, which is what we'd expect to see on wood, which is a known wood borer, but the stars show us some species that were surprises. Ostrophyleus from the Yaniridae and Zoromuna from the Munidae were species that were both abundant and unusual from sedimentary community. Now, Limnoria is a typical wood borer. I show you some images here of the European species, Limnoria lignorum, and the kind of damage it does to wood. The Limnoria that were collected in this series were blind and were occurring at much greater depths than has been known for species in this family. These samples plus sites off of California from over 3,000 meters. So this is a new record for the family, Limnoriidae. Now, deep-sea Munidae are extremely rare. I looked at the Woods Hole oceanographic sites, 219 samples in total. Zoromuna appeared in only 6 of them, and in all of these sites it was basically body fragments or bodies without legs. And indeed, the original description of Zoromuna cetofrons from the Peru-Chile Trench lacked any appendages. Now, we know that shallow water Munidae prefer firm substrates. I've seen them alive from Friday Harbor samples in particular. So, but before now, we had no idea what Zoromuna lived on. So here's the Zoramuna species, and one of the things that was really surprising is the incredibly long legs these guys have. The legs are more than 2 or 3 times the length of the body, depending on the leg, as is the antenna. So really, really large, shown in that female on the left. On the right, the other interesting thing is that the males have hugely enlarged first legs. So very, very surprising. It's amazing what you can see when you've got good samples of these things. Zoramuna is a dominant species. One wood sample had 118 individuals. It occurs in all of the wood samples from the Gorda-Wanda-Fuka Ridge sites, and it appears in very low abundance, maybe onesies and twosies from the backgrounds, the other samples that weren't associated with wood. And there's a much rarer species that occurred in only one sample. Now, these long legs were a cue that it's related to a subgroup of Monadae that are found in the southern hemisphere that also have the really long legs, and they also have the heavy claw-like first legs in the males. So very, very similar. And indeed, other aspects like the frontal ridge of the head, the cetacean, the uropods, and a few other things were very much like Zoramuna. This group is found only in the subantarctic and Arctic region, localities and other places in the southern hemisphere. And I should point out they have really well-developed eyes, whereas Zoramuna is completely blind, adapted for the lightless deep sea. The other surprising species, Austrofilius, is a new species. Previously we knew of 156 species from the Gulf of Mexico. And this species was not found in any of the sampling programs, both the Gulf, any of the samples that we've collected from there. But of course, they didn't collect wood, but this wood site had, from 614 meter, had 27 specimens. So Austrofilius really is targeting the wood. The other southern connection, Austrofilius species, for the most part, are found in the southern hemisphere, particularly around the Antarctic and subantarctic. They're common in shallow water and have well-developed eyes. But we do know of one species from the Mediterranean Sea at 47 meters. Unlike these guys, the Austrofilius 699 is completely blind. Again, it's adapted for the lightless deep sea, so it is a deep sea resident. The other species on the wood are, as I said earlier, typical of mostly sedimentary communities. All of them are rare and occur in only 1 or 2 samples. Most are members of the background assemblage, but I did want to mark a few of them with those little heart symbols as being possible epizoic. In particular, Haplomuna and Hebephaestus occur on stalk sponges off in the deep sea off California, and the Annulata species are known to occur on echinoderms and cnidarians in shallow water. So there is a preference for biological substrates in at least some of these species. Now, one of the things I was concerned about was whether this low diversity was influenced by the hydrogen sulfide that was in the environment. So I took a series of samples that I identified earlier from Fred Grassley's series done off of the Galapagos hydrothermal mounds shown there in the lower right area. Now this site is its similar site as the Galapagos Gorda Ridge system at 2,700 meters. Whereas the samples I'm studying are from 2,600 meters. Now I identified all of those isopods from the hydrothermal mounds of Galapagos. And so it was a good comparison to see if the background sedimentary community was affected by the hydrogen sulfide. And I also compare them to well-oxygenated samples from the Clipperton-Clarion fracture zone area. And I also showed the Gulf of Mexico site as just as a geographic comparison. Now this is the typical rarefaction plot showing the number of individuals rarefied down to smaller numbers from pooled samples. The y-axis, of course, is the expected species at lower numbers of individuals. And no surprise, the Gorda-Juan de Fuca Ridge samples are extremely low diversity. At 100 individuals, they're less than 8 species, whereas the Galapagos reducing sediments, shown in blue, are over 40 species. So this is really a clear indication that the reducing sediments in both regions wasn't really affecting the diversity. In fact, the Galapagos sites are approximately the same diversity as the well-oxygenated Pacific sites, as shown in yellow, green, and brown. So I've shown you that the wood faunas have low diversity locally compared to the background sedimentary fauna, and the different localities have very different taxa. Gulf of Mexico has Austrophilius, the northeastern Pacific has Zoramana. So if you looked at global species richness, it could be higher if each region has a different suite of species. So in summary, I've shown you unique isopods that occur on wood in the deep sea. These species are rare or absent in the background sedimentary fauna, and they appear to belong to clades that are found in the southern hemisphere. The wood isopods show low species richness, but hydrogen sulfide and reducing sediments don't seem to be a factor, since the Galapagos samples are really quite high species richness. And if you looked at the sum of all of the regional faunas, maybe global species richness could be high. So that's the end of the presentation. Thank you for your attention.